Hello, hello. We are in some heavy duty math, finishing up chapter 2, transforming equations and graphs of all different kinds of shapes, sizes, stretches, shifts left and right, up and down. We get to our final level, which is can we write the exact equation, including the stretch factor? And we are working with some parabolas. So right off the bat, guess what? We know everything is going to be dealing with an x squared. What's key? We're going to go ahead and find that vertex on every problem. We know that this is 20, right in the middle. The vertex is that middle point, 20, comma 10. So how do we take x squared and how do we change it so that it shifts and it transforms over to 20, comma 10? Well, remember we've been working with the x squared, but the x having a shift inside the parentheses. And I've talked about how do you think zero? How do you get that to zero? That's like your new starting or your new beginning. So we have a positive 20. So I'm going to put a negative 20 in here. Why? Why is it the opposite? Well, go ahead and plug in 20 and what happens? You plug in 20. 20 minus 20 is 0. Awesome. That's finding us our new starting point, our new vertex, our new locator point, whatever you want to call it. Cool, that plus 10, that positive 10 for the y, we just take that for free. Thank you very much. We do not have to change that or switch that or solve for it. It's just a shift up 10. In our couple videos ago, we talked about stretch factor being when you go over one spot to the right, how much is the graph shifted up or down? This is a decimal. I definitely cannot see it on the graph. So what do I do when I can't find that on the graph? I don't know what number to put up front here. Well, this is where variables get introduced into math. I know I saw online or something like the devil put the alphabet in math. No, it's just because we don't know what it is. I mean, you can call that a star or a empty box if you want and solve for the empty box. People just use variables because it stands for something. So S, we're going to solve for our stretch factor. Other books might use different letters. It literally doesn't matter. I can use Z for Zrenner. I just can't use X and Y because X and Y are already used there. So how the heck do we solve for that red stretch factor when there's a bunch of other variables in there? It's easy. You pick one other point. A lot of the times on parabolas, you're going to use your 0, 0 starting point, and you can see that the soccer ball will continue. I'm going to do exactly that. I'm going to use 0, 0 as my point to plug in. So I'm going to plug in 0 for X. Plug in 0 for Y. I am going to bring down everything else. I'll even color code it for you. Notice that everything else is the same. We just plugged in 0, comma 0. 0 for the X, 0 for the Y. Sweet, now we have one variable. We can solve for one variable. We can do that. It's possible. 0 equals the stretch factor times, let's go ahead and do parentheses. 0 minus 20 is negative 20. I'm going to go ahead and square it as well. Negative 20 times negative 20. You can use your calculator if you need to. I know that that's 400 plus 10. We need to solve for this 400s or this S400. We should not add 400 plus 10. That is not order of operations. That's not how we solve equations. So we need to get rid of this 10 here. So we have negative 10 equals our stretch times 400. How do we get rid of times 400? You divide by 400. Sweet. And we have solved for our stretch factor. You can leave it as a fraction. You can simplify the fraction if you want. I can divide negative 10 divided by 400. I'm grabbing my calculator. And I get a stretch factor of a negative and then a decimal point 0.025. That makes sense. When I go over one spot on this graph, it was down a tiny amount, but now I'm doing some engineering work here. I have found the exact stretch factor. So if I wanted to write the exact equation, I could just go rewrite this top one as y equals. Now I know my stretch factor. The x got shifted 20 to the right and 10 up. So now I got the whole equation just solving for that stretch factor. Woo! That took 5 minutes just for one problem. Well, guess what? We're in heavy duty. Algebra 2. Oh man, how do we do this if we do not have a graph? It's easy. We just draw a little graph. We just draw a little picture. Can we find the exact stretch factor for a golf ball hit in the shape of a parabola, 80 yards long? Boom. 20 yards high. Boom. Draw the parabola. Make sure it hits that 20 yards high right in the middle. Come on down. And let's go find that vertex. The vertex is going to be key. What is half of 80? Half of 80 is 40. This key point is going to be 40 over to the right, 20 upwards. Let's go ahead and do that heavy-duty math. Y equals, we do not know the stretch factor. We definitely don't know it. We don't have a graph to look at it, but I know it's going to be negative. When I go over one spot, it looks like it's going to be a negative. We'll double check when we solve it that we get a negative. We got our parabola, that's x squared, but it's shifted over to the right, 40, positive 40. Remember, we've learned to think zero, solve for zero. We're going to need the opposite, minus 40, to take us back to zero. And then we have our vertical shift of plus 20. Remember, you cannot solve for three variables at the same time. You cannot solve for three variables at the same time. So if I really want to solve for that s, for that stretch, I need to find an x and a y. I can use 0, 0. I can use any point that I want except for the vertex. We already used the vertex. What if I plugged in this point, 80, 0? Plug in 80 for x. Plug in 0 for y. Bring down everything else. Bring down everything else. Bring down everything else. Don't forget, bring down that s for that stretch factor. That's what we're solving. So I simply just plugged in 80 for the x, 0 for the y. Bring down the stretch, I can do 80 minus 40 is 40. What is 40 squared? Calculator, 1,600. I do not add 1,600 plus 20. I need to get s by itself. We should be undoing, we should be getting rid of that 20. Getting rid of that 20. We got negative 20 equals our stretch. That's good so far because I know the stretch is negative, right? It is a downwards parabola. So that looks good. We divide by 1,600. What is it? I don't know. I can leave it as a fraction if I would like. My stretch factor is negative 20 over 1,600. I know that that simplifies. I'm going to grab my calculator, negative 20 divided by 1,600. And we get our stretch is equal to negative. We got another decimal, a tiny decimal, but we're doing engineering work here, figuring out those exact stretch factors. Whether you keep it as a fraction, whether you keep it as a decimal, doesn't matter to me. Let's go ahead with a different color and come on back. You know how we used 80, 0? What if we use 0, 0 to plug back in? Let's go ahead and check it. What if I plugged in 0 for my x and 0 for my y? Well, this 0 is clearly the same. What happens when you do 0 minus 40? That's negative 40. What happens when you do negative 40 and you square it? You still get 1,600. So it doesn't matter which point you plug in, you are going to get the same stretch factor. Just remember, you cannot use the vertex. We already used the vertex in the first line, so then we're finding any other point to solve for how that's stretching. All right, let's go ahead to our last one. Nice. We've got a graph with a random point, but it doesn't seem to be the vertex. Let's focus in where we need to focus in. That would be a 6, and that is 1, 2, 3, 4. 6, 4 is what I'm using to make the general equation. Y equals, I don't know the stretch yet. I know it looks like it's going to be negative again, right? I don't know the stretch, but I do know that this x squared is going to move 6 to the right. We know how to do that. You've seen the video on that. You've seen it in class, x minus 6 squared. Then we got the plus 4. That shifts it up 4. We can't solve for three variables at the same time, so we go ahead and pick another point. Unfortunately, 0, 0 is not a nice point here. 11, 12, it's a decimal. I don't know what those are. That's why it's very clearly stood out that they have marked one of these points for us to use. Let's go ahead and use the 10, comma, decimal. It's all right. We know how to do this. Plug in 10 for the x. Plug in 2.4 for the y. Bring down the equals. Bring down the stretch. Bring down the minus 6 shift. Bring down the squared for the parabola. Bring down the plus 4 because it's shifted up 4. we know how to do this math. 2.4 equals our stretch. 10 minus 6 is 4. I like to do that next step all at once. 4 squared is 16. Bring down the plus 4. We do not add 16 plus 4. That's like if you were solving 16x plus 4 or 16s plus 4. You don't combine the 16 and the 4. So we need to undo it. We need to solve it. We need to get rid of that plus 4. Let's go ahead and minus the 4. Minus the 4. 2.4 minus 4. Grab your calculator if you need it. I did just to double check. Negative 1.6 is our stretch times 16. Go ahead and divide that 16 and we're going to get our stretch solved for. What is our stretch? Divided by 16 is a negative 0.1. Boom. We are doing engineering work here. I know it's heavy-duty math. I know there's a lot of steps, but the steps are all really just like middle school math. We're able to do that. That's a really ugly S. I just got really excited because we were doing engineering work. So yeah, we can solve for our stretch factor. No worries, okay? We got this. Look at the examples. Call me, ask for questions, throw stuff in the comments. How can I help you out? Good work. I believe in you.